Hello and welcome to the Administering SQL Server 2012 Databases, exam number 70-462, certification course offered by Simplilearn. This is the fourth lesson of the course, and we will introduce you to how to plan and use security mechanism of SQL Server in this lesson. Let us look at the objectives of this lesson in the next screen. After completing this lesson, you will be able to list the different types of accounts in SQL Server. Explain the uses of server roles. Demonstrate how to grant and deny permissions. Describe database roles. Explain how to work with database permissions. In this section, you will learn about the security model in SQL Server and the different types of accounts that are used in it. Let us get an overview of this model in the next screen. SQL Server security works using a concept called defense in depth. This is actually an extension of the Windows Server security model that too uses the same concept. It basically refers to adding multiple layers of security around the item you wish to protect. In this case, the data in SQL Server. Each layer that is added increases the level of security around the item. For someone who is not authorized to get in, trying to force his way in requires peeling each layer one by one, much like an onion. Every layer he peels reveals another to have to break. This model increases the security of the system significantly. In the case of SQL Server, it takes advantages of the platform it is already on, Windows, and extends it to itself. As shown in the diagram, this includes layers such as the network, Active Directory domain, Windows itself, and then finally SQL security. This, of course, leads to two types of accounts in the SQL Server. Let us understand Windows accounts in the next screen. Windows accounts are the accounts that are created in Windows itself. These could exist as local accounts on the server itself or be part of an Active Directory domain as domain accounts. In either case, these Windows accounts can be used as accounts in SQL Server directly. This is done by mapping the Windows account to a SQL Server login. The login encapsulates the Windows account as if it were one within SQL Server itself. We'll discuss login accounts very soon in more detail. Since the account actually being used is a Windows account, which comes with its own set of security features handled at the local or, more preferably, at a domain level, this type of account is actually the most secure form of logins that SQL Server can have. This is explained in the diagram. Note that there are three people trying to access SQL Server here. A user who doesn't have a Windows account is an invalid account at the level of the server itself, and is not allowed to access even the Windows resources, let alone SQL Server. The two other accounts are valid Windows accounts. However, only one of them has a mapping to the SQL Server system. So, while both are allowed to log into Windows itself and access resources there, only the one with their Windows account mapped to a login account in SQL Server is allowed to access SQL Server's resources. Let us understand SQL Server accounts in the next screen. SQL Server accounts are the other type of accounts that can be allowed to access resources within SQL Server. These types of accounts are actually added with the SQL Server system itself. Every instance of SQL Server can contain its own set of accounts, and resources are not shared amongst them. You also cannot use these accounts to log into Windows or the Active Directory domain. These are comparatively simpler forms of accounts stored within the server and are meant only for SQL Server resource access. As you can see in the diagram, whether you have a valid SQL Server account or not, you cannot use it to log into Windows. This is for two reasons. One, Windows requires much more secure accounts than what SQL Server can provide, and two, SQL Server accounts cannot be protected using Windows group policies. Due to this fact, SQL Server accounts are actually disabled by default. You can enable them in two places. The first is when you are installing the SQL Server instance itself. During this stage, you can enable mixed mode authentication. You can also do the same in the server's properties window after the installation. Mixed mode authentication refers to the fact that you can use both Windows accounts and SQL Server accounts. You might wonder, why not allow SQL Server accounts since that option is available for Windows accounts? As mentioned earlier, SQL Server accounts are not considered as strong as Windows accounts, and hence they are allowed only with the combination of Windows accounts. Wherever possible, try using Windows accounts instead of SQL Server accounts. If you do enable SQL Server accounts via the Mixed Mode Authentication option, it creates one SQL Server account called SA. This account is basically the SQL Server System Administrator, and you must provide a strong password for it. You cannot delete this account, and it has full rights on all resources. Let us understand login accounts in the next screen. As mentioned earlier, both Windows accounts and SQL Server accounts need to be mapped with SQL Server to allow access to its resources. This is done via what are known as login accounts in SQL Server. A login account, in most cases, is just a mapping for the Windows or SQL account to access a particular database. While you can create special login accounts that are standalone and not mapped, as in the case of contained databases we talked about in an earlier lesson, in most cases, these login accounts are used to provide access to one of the other account types to a database. A login account only provides the mapping and therefore authentication to access the databases, which means that the database will respond that the user is a valid user in the database. It does not provide rights, that is, the permissions on each object in the database. We will cover how that is done later in this lesson. In this demo, you will see how to use Windows and SQL Server accounts to log into SQL Server. You will also see how mixed mode authentication is enabled and mapping accounts with logins. We are currently logged into the SQL Server using the local Windows Administrator account of the system. To check the settings of what accounts are allowed, we need to go to the Server's Properties window, Security tab. As you can see, the setting is to use both SQL Server and Windows accounts. Note that there is no setting for just SQL Server accounts. Let's test this by trying to connect to the server using a SQL Server account. As you can see, we are using the SA account of SQL Server to log in. When we do, we connect successfully, and SSMS shows us the same set of objects that we could see logged in using the Windows account. You can see that both accounts, the Windows Administrator and the SQL Server SA, are present under the Logins node. Let's create a new login now for a SQL Server account. We have to provide its name and a password to log in. We can also change some password policies and the default database for this login. To add a Windows account to a SQL Server login, we first need to create the Windows account. For this, we'll open Server Manager, Computer Management, and create the account as shown in the Local Users section. If this was in an Add domain, we could create a domain account as well. We repeat the process of adding the login to SQL Server, except this time we have to choose the Windows account in the screen, rather than add the SQL Server account. Do note that some of the options are disabled as those are controlled by Windows. The logins you created haven't become users of the database as yet. We can add the Windows user login account to the database by providing the user and login names. We can do the same for the SQL Server login account by adding it to the database as well. Let's now try logging in using the other SQL Server account first. As you can see, the login completes successfully, and you can see the databases on the server. You cannot log in directly using the Windows login like this, as SSMS automatically picks up the account you've used to log into Windows. You can either log into Windows itself with the other login, or run SSMS as a different user by right-clicking the icon. This will bring up the Windows login prompt. Use this for the other account. You can now see that SSMS uses this other account for Windows authentication. And on logging in, you can see the database as with the others. In this section, you will learn about server roles, what they are, and why they are used in SQL Server. First, let us understand rights in SQL Server. Each SQL Server contains a large number of actions that can be performed on different parts or components. For instance, you can change different settings of the server, modify database properties, change table structures, and so on. There are many such actions that are defined. If you also have a number of logins, irrespective of whether they are based on Windows or SQL accounts, providing the rights to perform these actions to each login also becomes a major management task. Maintaining and managing logins to the rights they have on the server can become overwhelming quite quickly. And as this relates to the security of the system, one cannot ignore it either. In the next screen, we will discuss server roles. Correlating multiple logins with multiple permissions individually is not only inefficient, it can also become overwhelming, leading to mistakes and therefore reduce security of the system. Server roles can mitigate this by allowing grouping of multiple logins under a single name. You can then assign permissions to this role, which then applies to all logins within it. Server roles are the SQL Server equivalent of Windows groups. Just as in the case, multiple logins can be added into a group, and any rights assigned to the group gets assigned to the individual logins within it. In the case of server roles, the logins can be both Windows accounts and SQL accounts type. SQL Server comes with a number of server roles pre-built. These fixed server roles, as they are called, cannot be changed or removed. Only the members in each can be modified. That is, you can add or remove logins from these groups. We'll discuss these fixed server roles in the next slide. If you have administrative rights on the SQL Server, you can also create custom server roles and assign them permissions the way you want. First, we will discuss fixed server roles. As mentioned, There are a number of server roles that are pre-created by SQL Server, and permissions are also fixed beforehand. You cannot change the name or the permissions to these server roles. However, you can add or remove members from each of them. This will automatically assign or revoke the permissions to those logins. The first role, sysadmin, is fairly self-explanatory. It basically assigns all permissions to the members in it to the server. All activities on the server are allowed for them. Naturally, extreme caution and care must be taken with this role and the members within it. The next role, too, is quite powerful. The server admin role can change server-level settings for the current instance. Ensuring that only authorized members are part of this role is also essential to maintain security of the system. The security admin role is one where members have the right to manage security information of the instance. It allows adding and removing members from fixed server roles, including itself, and to create new custom server roles and manage its members as well. The process admin, while not as powerful as the first three, is still quite a powerful role. Members in this have the ability to start and stop services of SQL Server, such as the instance itself, the SQL Server agent, and others. The setup admin role is one that can change the components that are set up on an instance. That is, the members can run SQL Server setup and add or remove components from the installation. It can also manage linked servers by adding them to the current one. The bulk admin role allows its members to use the bulk insert command to enter large amounts of data from external files, such as CSV or XML formatted ones. The disk admin role has permissions that allow members to manage databases files on disk, such as the MDF and LDF files, their locations, partitions and partition schemes, file groups, and more. The DB creator role, as the name suggests, is one where the members have the right to manage individual databases. Members can create, alter, and drop databases from the instance. The public role, which is where all users are added by default, is the one with the least access to the system. As per the security settings, this role is a least privilege role, and every user is a part of it. Let us now discuss custom server roles. Logins with the right permissions can also create custom server roles. These roles are at the same level as the fixed server roles, but are completely manageable. That is, you can add, edit, and delete not just the members in it, but also the permissions assigned to them. You, of course, need to assign a name to the new custom role you create and add the accounts. Both Windows and SQL accounts are allowed. Adding these accounts to the role ensures that they are available for the permissions you assign. You can even nest roles within one another. You can make one role part of another role. This then cascades the permissions from the role that includes to the role that is included. To put it another way, if server role A includes server role B, then all the permissions assigned to A cascade to B. Also, specific permissions assigned to B also remain on it. However, if two permissions conflict with each other, it is the least privileged one that wins out. This is for security reasons so that someone is not granted a permission by mistake due to it cascading from any level. If any of the levels deny a particular permission, then that takes precedence. In this demo, we will look at both fixed and custom server roles, how you can add members to them, create a new role, and nest them and give permissions on them. Let's open the Servers Role node under Security in SSMS. As you can see, there are a number of fixed server roles already present here. On opening the sysadmin role, Note that the SA and administrator accounts are already here. You can also add or remove other accounts here, but there is no way to change the permissions here. It's the same thing for the other fixed server roles as well. Let's now create a new server role. In the dialog, we need to provide the name of the role and the owner of the role. Note the different types of securable objects we can assign permissions for. Let's now give some permissions for managing the current server to this new role. On selecting a securable, all the rights that are available are shown, and you can grant or deny here. A role needs logins so that the permissions are assigned to them. The Members page allows us to add and remove members as shown. You can modify the memberships as well as the permissions for this role at any time, as this is a custom server role, unlike in the case of a fixed server role that only allowed managing members and not the permissions. In this section, you will learn how permissions work in SQL Server and how to manage permissions when being assigned or revoked from a login or role. The next slide discusses the grant statement. The process of assigning permissions to a login or role is called granting. In fact, SQL Server has a TSQL statement called grant for expressly this purpose. The grant statement is used to assign different permissions to different levels in SQL Server. However, depending upon the level you need to use, the syntax differs slightly. When assigning a permission to the server level, all you need is the name of the permission, such as alter any database, and the name of the login or role you wish to assign that permission to. Doing the same for a different level, such as a database or table, also requires the object keyword followed by the double colon and then the object name. Both these methods will grant, that is, assign, the permissions to the role or login. The next slide discusses the with grant clause. The with grant clause is a special one that is optional for the grant statement. It specifies that the selected user will receive permission. This permission allows him to further grant the same permission to another person. For instance, consider if login A grants permission P to login B, but without the with grant option, and to login C along with the with grant option. In this case, login B will be unable to pass on permission P to any other login or role. However, login C will be able to further grant the permission P to login D, E, or F, either by extending the with grant or otherwise. For obvious reasons, the with grant option must be used with care. Giving this permission to anyone is not recommended and should be used only as a way to delegate the permission to other administrators to manage. Let us now learn about the deny statement. The deny statement is basically the opposite of the grant statement. It revokes the specified permission from the specified login or role. Even the syntax is similar to grant for both server and object level ones. Just like the with grant option, deny has a cascade clause. This basically revokes the permission from anyone that was given the permission through the with grant. As in the example of the previous slide, if login C had passed on the same permission to login D, along with the with grant, and login D had passed it on to login E, then if the deny with cascade option is used, the permission will be removed from login C, D, and E in one go. In this demo, you will see the effect of using the grant to assign permissions, with grant to allow further granting, and deny to revoke permissions. We created a new custom server role in the previous demo and assigned some permissions to it. Let's now use the grant and deny statements to do the same. We first identify the name of a permission we wish to grant. Note that this currently is not set for the role. After opening a new query window, we enter the grant statement with the name of the permission and the role to assign it. We can verify that it did get assigned by opening the Role Properties window and checking it. You can see it's been granted. Adding the With Grant option to the command also adds the ability for the logins to further grant the same permission. We can verify this by checking the permission in the Role Properties window. Let's now choose a different permission to deny to members of this group. For now, we select the Connect SQL one. Using the deny statement with the permission and the role name revokes the permission from the members. We can again verify that the role has been set to deny the Connect SQL permission. We can further verify this by trying to authenticate as one of the members of this role. We try to connect using the Mike B account. As you can see, this gives us a login failure as the account has been denied the Connect SQL permission. Let's now go and turn off the deny on this permission from the Properties window of the role. We can try connecting again. As you can now see, this will work without any problem. In this section, we'll see how the same set of security options work at the database level. We've seen the server level settings till now, so we can now proceed to the database level ones. Let us first understand database roles. Database roles are groups of logins that are created within a database. Each database can have a different set of roles. Database roles work similar to how server roles work, and even have two different types: fixed database roles and custom database roles. In the next screen, we will learn about fixed database roles. As with fixed server roles, there are roles fixed at the database level called fixed database roles. There are many such ones already defined, and we'll take a look at each one here. The first one is a role called DB Owner. This is like the system administrator for the database, and members of this group have full access to everything in the database. The next role is called the DB Security Admin. As the name suggests, it can manage the security of the database, including managing logins, roles, and memberships. The DB Access Admin role allows adding or removing both Windows and SQL accounts from the database. The DB Backup Operator role allows its members to run backups and restore databases to the server. The next role, DB DDL Admin, is one that can run data definition language statements, basically ones that can alter structures in the database. The DB Data Writer role is meant for members who can add, modify, and delete data in the tables. The DB Data Reader role allows members to query data from tables. The DB Deny Data Writer and Reader roles are ones that specifically deny modifying or even querying data from the database. Let us now look at Custom Database Roles. Custom database roles are those that are meant to provide specific groups to which you can assign database-level permissions. You can add both Windows as well as SQL accounts. While creating the role, you can also assign permissions in the GUI or use the grant or deny statements discussed earlier to assign or revoke them. In this demo, you will see how you can work with database roles in SQL Server. Let's take a look at the database roles for a database on the server. As you can see, there are a number of fixed database roles already created. The DB Owner role is the database administrator. As and with fixed server roles, you cannot change the permissions here, only the members. We now create a new database role called DB Query and add a login into it. Next, we need to find the objects to secure. In this case, we will find objects of a particular type, tables. On the tables, we are going to grant and deny some rights. We'll grant the ability to perform select operations, but deny delete operations. Let's now connect as the login in the database role we just created. As you can see, we're now connected as this user. We now open a new query window and issue a select statement for a table in this database. As expected, it works. Next, we issue a delete statement and execute it. This time it doesn't, as the permission to use this statement is denied to this login. Do notice that the select statement still works. Let's switch to the other connection and start a new query editor window. The select statement works here, and so does the delete. Here is a quick recap of what we have learned in this lesson. The different types of accounts in SQL Server are Windows accounts and SQL Server accounts. Server roles allow grouping of logins under a single name. The grant statement is used to assign different permissions to different levels in SQL Server, whereas the deny statement revokes the specified permission from the specified login or role. Database roles are groups of logins that are created within a database. Permissions on database objects can be provided as per requirements. This concludes the lesson, SQL Server Security. The next lesson focuses on Advanced Security in SQL Server.